Good morning, one and all. I am Professor Ram Khandare from first year engineering department, behalf of Dr. D.Y. Patil College of Engineering and Innovation, Parade campus. Today I will teach you the subject basic electrical engineering. The code is 103.0.4. The let's start with the unit number 2. The name of that unit number 2 is the electrostatics and the AC fundamental. This is the content which actually we are take the electrostatic flux, electrostatic field, electric flux density, capacitor, energy stored in the capacitor, charging discharging of the capacitor, generation of AC signal, fundamental of AC signal, leading lagging concepts, phasor representation. First is the electrostatic flux. We know that always force of imaginary force is present between the positive and negative charge, and always positive charge is directly forced towards that outward direction towards the negative, as shown in that diagram. That imaginary lines, that imaginary lines is called as a electrostatic flux. Second is the electrostatic field, the region in which the imaginary lines of a force and that imaginary lines of force is present, experience, it's called as a electrostatic field. The electric flux density, just density is nothing but the flux per unit area. The electric flux is nothing but the charge, so the charge per unit area, it's nothing but that one type of a that metal, where is actually the is ability to store the charge in that metal body. It's, we can say that the electric flux density of that particular body. So next is the capacitor. We all know the what is the capacitor is used to store the charge, always also we call as a condenser. The formula of capacitor, C is equal to epsilon 0 A divided by D. C is directly proportional to epsilon 0 A and inversely proportional to the distance. The second formula is a C is equal to Q divided by V. It means C is directly proportional to Q. It's nothing but the charges, and inversely proportional to the V. So you can see that see that there is a supply fed to that capacitor throughout that resistors. There is a charges will be the stored at the capacitor. After at the peak point, it will be the discharge. How it will be, we will see here. You can see that diagram. You can see that diagram. It is nothing but the capacitor. When the supply is on, the capacitor going to charge, and when the supply is off, capacitor is the discharge, and capacitor discharge through that LED. You can see here. So when the capacitor is voltage across that capacitor is equal to V naught e raised to minus t divided by RC, is the initial voltage, is the time period required to charge or discharge, and are actually nothing but the resistors through that capacitor going to discharge. So as per the current in that concept, that the capacitor is I is equal to V divided by R, and e raised to T upon RC. So is nothing but the RC constants. So we will take the next the energy stored in the capacitor. We can also derive the one derivation for that. E is equal to V into dq. So C is equal to Q divided by V. So V is equal to q divided by v is equal to q divided by c into dq. Integrate that, and that c is a constant, so 1 by c out of integration 1 upon q into dq. 1 upon q is equal q divided by c 1 upon, so we will get the, what we will get, the integrate c is equal to, c is equal to c is equal to q divided by v, so v is equal to q by c, and e is equal to, we can write v is equal to dq, q divided by c into dq. Out of integrating that, 1 upon c is out of that, q divided by 2 we will get q divided by 2. So 1 upon c is q square divided by 2 is equal to e, the c is equal to q divided by v, so q is equal to c into v square, so 1 upon c is equal to c, 1 upon c is equal to c square into v square, so c gone cancel, we will get half of c into v square. That derivation always asked in the exam, it's a very easy derivation. But actually we have to, e is equal to v into dq, v is equal to q divided by c into dq, we have to take the separate from an integration, we will get the 1 upon c integration of 1 q divided by, so integration of q into dq, integration of q is nothing but the q square divided by 2, we will get the 1 upon c into q square divided by 2, q is equal to c into v, c square into v, c gone cancel, we will get the half of cv square. It's very easy. Now we will see the generation of AC fundamental. First upon that we will consider that what is alternative current. The current having the both polarity, frequency is 0, such a signal we can as the alternative current. As per the Faraday's first law, when any conductor placed in the magnetic field, it cut the fluxes and the induced EMF, it will be the generated inside of that conductor or that body. And second Faraday's law state that the rate of change of flux with respect to time is the E is directly proportional to the rate of change of flux with respect to time. So as shown in diagram, how the AC signal is generated, we have kept the north and south pole in front of each other. The imaginary lines is built between that, because force of attraction, we all always know that different poles having the force of attraction. So just the Faraday's first law, any body kept in the magnetic field, when induced EMF generated inside of that, when it will cut the fluxes, so that coil is supposed to be, this coil is supposed to be parallel, the coil is supposed to be, that coil is supposed to be parallel, it means that it will not cut that imaginary lines, it start with the 0, when the it will perpendicular to that imaginary lines, and then totally lines it will be the cut, then we will get the maximum. Then after that it will be the horizontal, we will get the pi. After it is a vertical, we will get the 3 pi by 2, it's a maximum, and here is a 2 pi. So it such type of a AC signal can be generated by using that coil. So what actually we can say that it is nothing but the one cycle. What is the one cycle? One positive and one negative, set of the one positive half cycle and set of the one negative half cycle we call as a portion. Set of one positive portion and set of one negative portion we call as a cycle. What is the period? Time required to complete one cycle called as the period. Reciprocal of period we call as a frequency. Maximum value attained by that alternative quantity, we can say that it's the amplitude. Maximum positive portion and maximum negative portion we call as a peak to peak value. It's all that simple concept behind of that the AC signal. It's a cycle, just we have discussed what is the cycle. one set of positive and set of negative portion of alternative quantity, we call as a cycle. What is the amplitude? Maximum value attained by that alternative quantity, it's called as amplitude. Maximum positive portion and maximum negative portion, maximum positive portion, it's called as a peak to peak. Time required to complete one cycle, it's called as a period. And what is the frequency? Reciprocal of t, it's called as a frequency. It's nothing but the lagging. What mean by the lagging? And what is the two alternative quantities? When we having the two alternative quantities, we start with the positive. Okay, we can say that the difference between the two alternative quantity is a positive. The difference between two alternative, it's suppose current alternative quantity and its voltage alternative quantity. The difference between two alternative quantity, it is a positive, we can say that it is the leading. And the difference between two alternative quantity, the difference between the two alternative quantity is it's negative, we can say as a lagging. We can say that the lagging, and it's a positive, we can say as a leading. What is the definition then? Leading means that the difference between the two alternative quantity is always positive, we can as a leading. And the difference between two alternative quantity is negative, we can say that it's a lagging. It's a phasor diagram. Always we can say that when the phasor difference between the two alternative quantity is supposed to be positive, we can say that is a leading. So it's supposed to be voltage and it's supposed to be current. Current is lead to the voltage and voltage is lag to the current. It means that it's a lead. If supposed to be the voltage and it's supposed to be the current, here is the voltage is a lagging, here is the current and voltage are in the same space, same. It's meant it's a phase difference is a zero. Phase difference is zero, we can say in phase. Phase difference is a negative, we can say lag. Phase difference is a positive, we can say that it's a leading. It is a very simple phasor diagram, always ask in the exam. Phasor representation. And thank you to all. Thank you so much to all to listen.